Hi everyone, how are we doing? So, I don't want you to get upset by what you're looking at, but I just want to take a deep breath and trust me, it's not that bad. So, this is the equation we ended up with on the last lecture, where we had YCT is equal to, and I realize I've got a little mistake here, this is 3. This is alpha cubed YCT minus 3 plus ET plus alpha ET minus 1 plus alpha squared ET minus 2. Now, I haven't provided the intuition yet, but we're getting close. So, what I want to do is just keep on substituting. And then I'll explain the intuition, which is actually relatively straightforward. So, if we keep on substituting n more times, okay? You've seen you substitute for CT minus 1, CT minus 2, and so forth. Now, if we do it n more times, it's going to look like this. YCT equals alpha to the nth power, and that's the amount of times we substituted, times YCT minus n periods back, and n could be years, plus ET, plus alpha ET minus 1, plus alpha squared ET minus 2, and then I just put a plus sign with the dots to go to alpha n ET minus n. Okay, so again, all I want you to do at this point is to understand mechanically what we've done, and we're going to come up with the intuition in this last equation. So, here's where we are right now if we've substituted n times. Now, since alpha is a fraction, 0.5, 0.6, if you raise a fraction to a higher and higher power, it gets smaller and smaller and smaller. Okay, like if you have 0.5 and you raise it to the second power, it's 0.25. If you raise it to the 10th power, it's getting close to 0. So, what we have here is, as n goes to infinity, we really don't have to go to infinity, but as n gets large, alpha n approaches 0. This variable parameter times that raise the nth power gets smaller and smaller, essentially 0. So, what you end up with here is this last equation. And this is what we need to explain. And it's actually, again, relatively straightforward. What we're saying is the cyclical component of output is a function of the demand shock this period, okay? But we see when you look at the shock last period or last year, it has a reduced effect because it's multiplied by this fraction. And then as you go back 2 periods, it's ET minus 2, but it's raised to alpha to the second power. So alpha to the second power is a smaller value than alpha to the first power, or just okay. So what we're seeing is you go further back in time, the impact of these shocks on the cyclical component of output today gets smaller and smaller. And I guess an example would be is that you may, when you were a freshman in college, you may have something that happened which may have upset you or may have been a good thing, but then over time, that event probably becomes less and less important. All of you can come up with an example like that. Like as an example, a couple of weeks ago, I'm working out and I pulled the calf muscle a little bit. So, it slowed me up a little bit. But over the next couple of weeks, that calf pull got less and less and less, so the impact of that shock 2 weeks ago today became smaller and smaller. Okay, so that would be an example, a personal example of a physical injury. So, but again, what we're saying here is we did a bunch of algebra, and what we decompose YCT in is equal to a demand shock in period T, ET, a demand shock last period, which is multiplied by alpha, but since alpha is a fraction, the impact of ET minus 1 is smaller in period T. And if you go back n periods, that alpha to the nth power could be very, very small. So therefore, the impact of ET minus n, that demand shock n periods ago, is very small on its impact on YCT. But if you remember, we were doing dynamic modeling with the solar growth model. We were showing how a movement to the steady state over time or over periods, if you're away from the steady state, how you'll naturally move to the steady state. But that was over time. And this is over time as well. Now we're looking backwards. We can actually look forwards, but that's not critical for right now. So, what I'm going to do is solve out for YNT in the next lecture, and then we shall keep on going. So I'll probably get about 2 or 3 more lectures of 5 minutes apiece to understand this, and then I'll have a summary lecture to figure out all the intuition. Okay, see you guys later.